All right, so today we're going to talk about dilations of shapes. So let's get right into it. Well, what is a dilation? That is when a shape either gets larger or smaller. We use the term enlargement to describe a shape getting larger, and we use the term reduction to describe a shape getting smaller. In order to dilate a figure, you need a scale factor, which is a number that you're going to multiply your coordinate points by. So, if you have a scale factor of 2, what will the dilation for points 1, 3, negative 7, 2, 5, negative 4, and negative 3 and 3 be? In order to find that out, we are going to take our scale factor of 2 and we're going to multiply every number in all of our points by 2. So 1, 3 becomes 2 and 6. 1 times 2 is 2, and 3 times 2 is 6. Negative 7, 2 becomes negative 14, 4. 5, negative 4 becomes 10, negative 8. And negative 3, 3 becomes negative 6, 6. So then you have your new points, and you would just go plot them. What you'll find after you plot these points is that your shape has gotten larger. It is increased in size. It is an enlargement. In fact, it's doubled in size. It's been multiplied by 2. All right, so let's look at this next problem. If you have a scale factor of a half, what will the dilation be for points 1, 3, negative 7, 2, 5, negative 4, and negative 3, 3? Once again, we have to multiply all of our numbers by a half. So here's what we get. 1, 3 would become 1 half, 1 and a half. 1 times a half is a half. 3 times a half is 1 and a half. Negative 7, 2 will become negative 3 and a half, 1. 5 and negative 4 will become 2 and a half, negative 2. Negative 3, 3 will become negative 1 and a half, positive 1 and a half. And once again, you just take these points and you would plot them and get your new figure. And what you should find with this figure is that your shape has reduced. It's a reduction. It got smaller. In fact, it's been cut in half. So something that's kind of a little trick, whenever you have a scale factor and you want to try and figure out, should my shape be an enlargement or a reduction? All right, when your scale factor is a whole number, or anything really larger than 1, then you're going to have an enlargement. If your scale factor is a fraction or a decimal, something smaller than 1, then your shape is going to be a reduction. Okay? Let's do some more here. We're going to dilate the points according to the scale factors. We won't do all of these. There's kind of a lot. All right, so we're using the scale factor of 2 and the scale factor of a half for each of these problems. So the first set of points, we're going to use the scale factor of 2. So we're going to multiply all of these points by 2 to get our new points. 2 and 5 will become 4 and 10. 9 and negative 6 will become 18 and negative 12. And 4 and 4 will become 8 and 8. All right, pretty simple. Coming down here, let's do the bottom problem. So we are going to use a scale factor of a half for all of these. 1 and 3 will become 1 half, 1 and a half. 2 and 4 will become 1 and 2. 5 and 7 will become 2 and a half, 3 and a half. And 6 and 8 will become 3 and 4. Now, if you're a little squeamish about multiplying by a fraction, If you haven't figured it out yet, multiplying anything by a half is the same as dividing it by 2. All right, so whenever you are using the scale factor of a half, you're actually dividing your original values by 2. All right, so that should make it a little bit less scary. Okay. All right, we're going to plot the original points, and then we are going to dilate it with a scale factor of 2 on my wonky grid. All right, so let's do the originals. So the originals will be 1 and 3. 1, 1, 2, 3. And then 4 and 3. 1, 2, 3, 4, and 3. 2 and negative 2. 1, 2, 1, 2. All right, so here is my original shape. This triangle. Now I'm going to dilate it with a scale factor of 2. So I'm going to get new points. So my point here will become 2, 6. This point will become 8, 6. This point will become 4, negative 4. All right, so let's plot them. 2, 1, 2, and 4. All right, 1, 2, 3, 4. This point is, oh, I'm sorry, that's 4. That is 2 and 6. My writing is not very good. 2 and 6. All right, we'll say there we are. All right, 8 and 6. 1, 2, 3, 4, 5, 6, 7, 8, and 6. And 4 and negative 4. All right. So as you can see, my triangle has enlarged. It has gotten much bigger. All right. Okay, well, what if you have the points of your dilation and your original, and you need to find the scale factor? In order to do that, you would divide the points from the dilation by the points from the original figure. And you have to do x divided by x and y divided by y. Okay, so make sure you are following that order. So in this pair of points, we've got the dilation, which is 2 and 4, and the original, which is 1 and 2. So we would divide our x from the dilation of 2 by the x from our original, which is 1, and we would get 2. All right, we would divide our y from our dilation, which is 4, by our y from our original, which is 2, and we would get 2. So our scale factor is 2. All right, our scale factor is 2. Here we have another pair. We've got our dilation, which is 1 and 3, and our original, which is 2 and 6. So we would divide 1 by 2. All right, it's x divided by x. Remember that. X divided by x, 1 divided by 2, which would give us 1/2. And 3 divided by 6, which again gives us 1/2. So that's our scale factor for this figure. All right, so you're dividing dilation divided by original. Make sure it's x divided by x, y divided by y. Okay, here we have a couple figures. This is the larger triangle is the dilation, and the smaller triangle is the original. So let's find the scale factor. All right, what you may notice at first is that we do not have any points. And we need at least a pair of corresponding points. So you don't have to identify every pair of points on this figure. So let's just pick a pair of corresponding points. So I'm going to go with these points up here. Now this point is 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 5, 15 is this point. Now the corresponding point on the next triangle is this one. So let's find our x and y. 1, 2, 3, 4, 5, 6. Okay, about 6.5 or so, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it's like 6.5, 10. All right, so you'd set up your division. Just for the sake of time, let's do, all right, it's always got to be dilation divided by original, so let's do 15 divided by 10. We get a scale factor of 2.5. All right? So that is how you do that. Thank you once again.